Okay, hi guys. So we'll be seeing some more questions on Eudiometry. Okay, so let's get started. So we have 10-liter mixture of C2H6 and C3H8 at 1 atm and 273 Kelvin. Okay, on complete combustion, gave 24 liter of oxygen, or rather 24 liter of carbon dioxide. So you have to calculate the composition of original mixture. Original mixture with, or rather in terms of volume. Okay, so we have C2H6 G reacting with 7/2 moles of O2G and converting itself into 2 moles of CO2G plus 3H2L. Okay, so we have this in as, let's say, V volume, then 7/2 volume V volume will be required in order to produce 2V of CO2. Okay, and we also have C3H8, which on reaction with 5 moles of O2G will give 3 moles of CO2G plus, this would be negligible, and 4 moles of H2O. We are again neglecting this. So again we are having 10 minus V volume of C3H8, which will require 5 into 10 raised to power 5 into I beg your pardon, 5 into 10 minus V, and forming 3 into 10 minus V volume of CO2 gas. So we know that 2V plus 3 10 minus V is 24, which is given in the question that 24 liter of carbon dioxide was produced. Hence, solving this equation, we get minus V plus 30 is equals to 24. Hence, V would be 6 liter. Okay, and that would be the answer. Okay, so we get to know that C2H6 was present at 6 liter and C3H8 was present in 4 liter volume. Okay, so this is the answer. Now let's discuss contraction due to absorption of gas. Okay, so let's say we have KOH aqueous solution. Okay, so if we pass 50 ml mixture of CO2 and O2 gas, what we get is only 30 ml of O2. So CO2 absorbed would be 20 ml, and hence we get to know that in the initial mixture 20 ml of CO2 was present. Similarly, if we have a box of turpentine oil, then if we pass, let's say, 30 ml mixture of O2G and O3G, then we would be obtaining O2G at the end, and which is 10 ml in volume. Hence we get to know that O3 absorbed, or O3 in the initial mixture, was only 20 ml. Okay, now let's do a quick question on the same. So suppose we have a mixture of CH4 and C2H4 in volume ratio of X is to Y. Mixture of CH4 and C2H4 in the volume ratio of X is to Y, then it has a total volume of 30 ml. On complete combustion. It gave 40 ml of CO2. Okay, so if the ratio had been Y is to X instead of X is to Y, what volume of CO2 has been obtained? Has been obtained. Okay, so we have CH4 plus 2 moles of oxygen forming CO2 plus 2 moles of CH2, 2 moles of H2O, and we have C2H4 again reacting with 3 moles of oxygen to form CO2, 2 moles plus 2 moles of H2O. So here it would be using X moles of CH4 with 2x moles of O2 to form 2x or other X moles of CO2. And here it was initially having Y moles, consuming up Y moles and forming 2 Y moles of CO2. Now we know that X plus 2Y is equals to 40, which is volume of CO2 observed. Okay, and we also know that the volume ratio of X plus Y is, or rather we know that X plus Y is equals to 30 ml, which is given in the question that the volume ratio of CH4 is to C2H4 is X is to Y, and the total volume they take is 30 ml. Okay, so from these two we can calculate the value of Y, which should come out to be equal to 10, and the value of X should come out to be equal to 20. Now you can just reverse the equation in which presently X is to Y is 2 is to 1. You can have a ratio in which Y is to X is 1 is to 2. Okay, so for this part you can again calculate that if Y, rather this is 10 ml and this is 20 ml, then this would be formed 10 ml and this would be formed 40 ml. Hence the answer would be, if the volume ratio was 1 is to 2, then the answer would be 50 ml of CO2 would be formed in the reaction. So with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the same.